Hello everyone. Today we will be taking a look at Docker. It is one of the hottest technologies in the DevOps space right now. Okay, let's take a look at the agenda. We'll answer the question, what is Docker? We will discuss why we need Docker, Docker versus VMs. We'll look at Docker Hub. We'll go over the Docker basic commands. We'll discuss Docker images, and we'll see the Docker demo. So what is Docker? Docker is basically a container engine, and it allows you to run your applications inside containers. Now, until now, we've been running our applications in virtual machines. Every virtual machine used to be the base of our application, but now with the advent of Docker and containerization technologies, each application is run in a container-like logical space. So to define a container, it is a logical grouping of all the binaries and all the dependencies that each application requires, and then bundling it into a single whole and running it on top of a Docker engine. Docker is typically used to run applications, typically like microservers, which are single bundled applications. Now, they don't really depend on a lot of external factors. Now, the benefit of having applications in containers is that you don't really need to worry about the base infrastructure. You just need to make sure that you have the Docker engine running, and that will make sure that the container is running in the same way on any platform. Docker is open source, so you don't need to pay to use Docker, at least the open source version or the community edition. The enterprise version has been recently launched, and it has a few more features. But I have seen many projects implemented with the open source version, and it is more than enough for what you need to get your basic applications containerized. When we talk about Docker, it's kind of like a mini platform as a service. So in a normal platform as a service offering, what you get is just the actual thing that you need to run. So let's say you are using Elastic Beanstalk on Amazon Web Services. You get a Ruby platform on which you can run your application. Now with Docker, you get a real platform, but just the platform required to run your application. And that is more than enough to get yourself into production. Docker integrates easily with other tools, so it integrates with other ecosystem tools like Swarm, which is a cluster management system. It integrates with monitoring systems. You can monitor things on the user ports using Nagios or any other monitoring system you've been using within your existing infrastructure. You can monitor the base hosts in Docker, on which Docker actually runs using your normal monitoring tools. So why do we need it? What is the benefit of using Docker? We're really good on VMs, and we've been running them for the last decade. So what's the real need to go to Docker? Well, the first thing is you get really efficient utilization of your resources. Now, let's say I've got 10 VMs, and I'm running 10 applications on VMs, and things are good, but the only problem is VM number 4 is at 50% utilization. So I'm actually wasting half of capacity on VM number 5, and on VM number 6, say I'm just using 40% of the entire power I have. So in that case, a lot of the provisioned capacity goes to waste. Now, in order to use that space and capacity in a more efficient way, you need to have some sort of mechanism which abstracts the base hardware allocation and the application. Now, Docker forms the best combination for that. So it allows you to run your applications in containers, and at the same time allows you to optimize your resource utilization. So let's say you're on 10 VMs earlier and you were running 10 applications, and when you move to Docker and you've Dockerized your applications, you can use those same 10 VMs and on top of those VMs run a cluster of Docker containers, and those 10 VMs now will be available as a whole to Docker Swarm or any other cluster management system, and you can run all your applications across those 10 containers. So in effect, those 10 VMs would be available as a whole for the containers to easily run anywhere. You can actually bump in more containers on the same number of VMs. So let's say you were on 50% utilization and you want to increase the utilization, and you can actually run more containers, so you could actually get up to 90% utilization of the same hardware. So with this, you easily get scalability, since you can scale up or scale down any cluster management system. So if you're running Docker Swarm, for example, you can scale up your containers to any number just by a single command. You get the portability of the cloud as well as Docker containers. Let's say you are on AWS Cloud and you want to move to Google Cloud. You can import your containers to Google Cloud just by running a Swarm cluster there and then porting the image, and that's it. You don't need to worry about any networks for anything else. You just run your application on top of Docker Swarm or Docker Engine. Now, with this portability, you get the advantage of having multiple environments, and with those multiple environments, you can have disaster recovery in place. Disaster recovery will give you a high availability, and your business will never be down. That's one of the biggest advantages of Docker, and you can easily set up DR zones in your environment. Now, let's compare Docker with VMs. Docker's fast. You can run a Docker container like in 1/120th of a second, whereas a VM takes almost 3 minutes to boot up if it's a GUI VM. If it's a CLI VM, it takes almost 1.5 minutes to boot up. So Docker containers are lightweight since they follow the layer file system approach. Any Docker container, which is like a base image, would be around 120 to 150 megabytes. Now, if you look at a VM OVF file or a VMDK file from VMware, you'll find that it's almost 2 gigabytes for the CLI version, and for the GUI version, it's more than 4 gig. Docker containers are portable. You can easily port them by committing them to a Docker hub and then importing them elsewhere. VMs are not that portable. So let's say you've got a VM in a VMware sphere in your house, and you really have to import that entire image using a PIM drive or some sort of network share, and it takes like 4 or 5 hours to do the transfer. So the portability aspect for the VMs is less desirable. Let's talk about Docker Hub. Just like you have GitHub for code, there is Docker Hub for Docker containers. Now, Docker Hub is used to store Docker images and share them as well with the community. Docker Hub has both open source and pay repositories. So it's an open repository managed by Docker Inclusive. So they have it for the community. So you can get one private repository and unlimited public repositories for free. On the Docker Hub, you've got official images of almost every software on Earth, like Nginx, Apache 2, Enterprise Edition images. It's a hosted solution for private repos, so if you pay Docker Hub for private repositories, you can get a cloud-hosted solution there, so you don't need to manage a local repository in your infrastructure. There are some Docker basic commands, which we will take a look at in the demo. There is a Docker PS that is used to show how many containers are running. Docker pull, which allows you to see and pull images from the Docker Hub. Docker run is used to run Docker containers. Docker images will show you the images you have in your local repository. Docker attach will attach to the shell of a running container. Docker stop will stop a running container and will start a stopped container. Let's take a look at the demo. So I've got a Linux machine here on Ubuntu 16.04 command line version, machine ready, set up. It's running on a virtual box, and I'll be using the terminal on my MacBook to access the machine. We'll proceed with the installation of Docker on that machine first of all. Then we'll pull some images from the Docker Hub. We will also try to run some containers, and then we will look at the usage of some normal commands. Then we will try to make some changes in the image and commit to the local repository and push it to the Docker Hub. So that will be all for the demo. So this is my Ubuntu 16.04 image. So you see LSB_release-A. You see it's Ubuntu 16.04, codenamed Xenial, and it's the latest LTS release. We'll be using apt first of all to install a couple of dependencies which Docker has. So I'll say apt-get install apt-transport -https ca-certificates curl software-common-properties -y. The -y is used as a yes to automatically accept the agreement. Pretty much all of these are there by default in the installation of Ubuntu, so you don't really need to worry about those, but just as a security check, we did that. Now the next step, we are going to download the GPG key of Docker from the official repository, so they host it at download.docker.com. The reason we need to have that is that we want to make sure we don't get any spoofed packages. So we do a curl -f. So I'm doing it in the silent mode using these switches because I'm going to pass that the apt-key add command. It's hosted on https download.docker.com /linux/ubuntu/gpg, and I'll pipe it to the apt key command. So I'll say apt-key add -. So what this will do is get the GPG key from the Docker repository and add it to the local apt cache. Okay, Okay, have pressed it. It should say okay. So this means the key is added now. Now I want to add the repository for the Docker installation. There's a remote, but my local installation doesn't know there's a remote repository. So I'll be using the add-apt-repository command to do that. So I'll say add-apt-repository to do that. And then I'll say deb arch equals AMD 64 https download.docker.com/linux/ubuntu, then $lsb release -cs, and then stable. This command will add the repository to my etc apt sources.list. So if I open the file and etc apt, if I open the sources.list file, you'll see so I've added the AMD 64, which is the 64-bit version, since my machine is 64-bit. So if I do a uname-a, it says x86-64. So I want a 64-bit machine, and that's why I've added the 64-bit repository of Docker. Next step I want to do is update my apt caches, because I want to get the latest package indexes. So I'll say apt-get update-y. After updating the local cache, I need to restore the Docker Community Edition, so I'll use the apt command again. apt-get install docker-c-y. This will install the Docker Community Edition on my local machine. It will fetch all the repository packages. Now Docker's installed on this machine. Let me check and see what version of Docker I have. So I'll do docker -version. So you see I have Docker version 17.03.1 Community Edition, build C6D412E. The next thing I need to do is I need to go and run a Hello World container, because that's like a health check. So I'll say docker run hello-world. We'll do a couple of health checks in the background. Now you see it says unable to find the image locally, pulling file system layer from Docker Hub. And it gives me this nice clean output that says hello from Docker. This message shows that your installation appears to be working correctly. To generate this message, Docker took the following steps. So basically it did a whole lot of health checks in the back end to contact Docker daemon. Then the Docker Hub was contacted, the image was downloaded, so everything seems to be fine now. Now I'm going to download a couple of images there, so the first thing you do is you search for those images. So I'll search for the Ubuntu image, so I'll say docker search Ubuntu. So you see a lot of images are out there, of which only the first one is an official one. So you see this is official, okay. So I'll download all 4 major versions. So I'll say docker pull Ubuntu. This will pull the Docker Ubuntu image. So you see it's pulling down the layers. I'll pull the Fedora image. These are the 4 most popular versions. So I'll say docker pull Fedora. Docker pull Debian. And then docker pull CentOS. That's the 4th one. So all of these images have been pulled from the Docker Hub. Now let me give you a quick look at the Docker Hub. So if you go to hub.docker.com, If you go to Explore, you'll see almost every major software is in there. Nginx, Redis, BusyBox, Ubuntu, Alpine, Registry, MySQL, Mongo, Elasticsearch, Logstash, Node, Hello World, Swarm, HTTPD, everything. So I've pulled 4 images here. So if I do a Docker images, it will list out all the. So in addition to the Hello World, I've got 4 more images, which I've pulled down. So you see, it shows me the tags, which is the latest. There's an image which corresponds to a unique image ID on the Docker Hub. It shows me the created date, 6 days ago, 12 days ago, whatever date image was created, and the size. So you see the size is considerably small. 119 meg, 100 meg. The Hello World is just 1 KB. CentOS is just 193 MB. Fedora is 231 MB. The next thing we're going to do is I want to run the containers. So let me run the Ubuntu containers. So I'll say docker run -ti Ubuntu. So this will run the Docker Ubuntu image in interactive mode. So I'll be able to switch to this container. So you see the prompt will change now to root at 480. So I'm inside the container now. So I'll do a free -m, and the container has the same amount of memory as the base machine. So let me go to the base machine. So I'll open up a session to the base machine here. Okay, now in this image, root at this is the container. If I do a free hyphen here in the base machine, you see almost the same amount of RAM is free. So this means Docker containers use the same RAM that is available on the base machine. Now I'm going to do a docker ps-a here. It shows me that there are 2 containers running. One has the Hello World container, which I ran 4 minutes ago, and was used just as a health check. And then you see there's a Ubuntu container running, and its name has been given randomly by the Dr. Damon as Happy Pasteur. So this container is running in the background, and it's up in this VM. Now we're going to stop this container using the docker stop command. So I'll say docker stop, and then the container ID. This will stop the containers. So if I do a docker ps-a, you see it shows that it has exited. But I can restart this container by doing a docker start. And then I can attach to the command line of that container using the docker attach command. You see I've restarted it, and I was able to attach it. Now let me exit from this container and let me remove all the containers. So the command to remove all the containers is docker rm, and then the container ID. Now you can see I have 1 container remaining. I've removed all of them at once by just doing the docker rm. And then in brackets I'll be placing docker ps-aq, which will get all the container IDs. Now if you run it as a standalone, you'll see docker ps-aq gives you all the container IDs. Now let me run 1 container in the background once I do docker run -ti-d Ubuntu. So you see it's running in the background. So if I do a docker ps-a, there's a container, agitated Euler, running in the background. I can attach to that container by using the docker attach command. Docker attach, and then the container ID. Now let me update this container and make some changes so I can commit to the Docker Hub. So I'll say apt-get update -y. This will update my Docker container to have the latest package indexes from the Ubuntu repositories. Now I'll do an apt-get, so I'll install the Apache web server on this. So I'll say apt-get install Apache 2-y. This will install the Apache 2 web server actually on this container. I'm doing this because I want to save the state of this container on the Docker Hub. So this is downloading the Apache 2 from the remote repositories. Then I'll start the Apache service. So I'll say service Apache 2 start. So if I do a service Apache 2 status, you will see it is running. Now the next thing I want to do here is exit from this container and then try to commit it. So I'll use the docker commit command and to save the state of this container. So you see docker ps-a. This is the container for which I'll save the state for. So I'll say docker commit-m. This is the commit message, so I'll say installing Apache web server. And then I'll say author name Amir, and then container ID and the name, which I won't put. Now, there's one thing which we need to take care of here. You have to make sure that your image has the following formatting. It should be your username on the Docker Hub, Amir Ahmad 170, / whatever your container has. So I'll say Ubuntu-Apache 2. Now, when I commit this container, it comes into the local images list. So if I do a Docker images, you can see it's here. Now, I've got to push this to the Docker Hub, so I'll say Docker login-u. Log into the Docker Hub from the command line using my username. So I'll say docker-u Amir Ahmed 170. I'll give it my password. So I'm logged into the Docker Hub now. It says Docker login succeeded. Now I can commit that image, so I'll say docker push. I've already committed it, so I'll push it now. So I'll say docker push and then the image ID. So if I just do a push here, it's doing this. But in the meantime, if I go to my dashboard, I already have two things here. And in a moment, you'll see one more here. So it's pushing all the layers of the image. And then once you push this, I can just remove my local thing. So when I refresh this here, you'll see a third image coming up here. Actually, it has over it in the one I already had. So let me just delete and repush this. I'm going to clean up my Docker Hub here. Delete. I'll delete this one as well. Delete. Delete. Okay. Now if I push again, you'll see it will create a new image here in my Docker Hub. It will take some time to do that, but that would be a confirmation that the image has been pushed from my Docker machine here. So it's pushing 137 MB of the image layer, the top layer. So you see this is pushed. So now the basic idea behind this pushing was I really wanted to keep this saved in the remote Docker Hub. So I'm going to remove all my local images. So I'll say Docker images. Okay, I'll remove all of them. So I'll say Docker. First, I'll clean up my container. So I'll say Docker RM. So there's no container running, so I'll remove all the images locally. So I'll say Docker images, and then I'll do a Docker RMI-F. So I'm removing it forcefully. But I'll do the single command remove, so I'll say Docker images -AQ. This is a single command remove. It basically gets all the image IDs in this command, so let me show you this. Right now there is no image, but it will put all those image IDs here and forcefully remove all those images. So if I do a Docker images, no Docker images there. If I do a Docker ps-a, no container is there. Now let me run the container from here. So I'll pull the image first using this command. So the beauty of Docker Hub is that it gives you a command for pulling the container. So I'll do docker pull Amir Ahmed 172 / Ubuntu-Apache 2. So it statically goes to the Docker Hub. It's pulling the layers from there. Then I'll do a docker run -ti. And then the name of this, so running this in just a moment. I'll be running this in the interactive mode. And once if I do a history, you'll see the commands that I ran: apt-get update, apt-get install, service Apache to start, service Apache to status. So this is how you push images to the Docker Hub and then pull them from there. So this is all that we have for Docker. Thanks for watching this video and have a nice day.
Hey, want to become an expert in cloud computing? Then subscribe to Simplilearn's channel and click here to watch more such videos. To nerd up and get certified in cloud computing, click here.